So welcome back to the series of video for the nanoparticle synthesis in which today I am going to describe how you can prepare the nanoparticle through co-precipitation method. So for the co-precipitation method, you know that there are two salts and you have to mix them and then you have to add a base and then you have to stir, and after stirring there will be the formation of precipitates, and then you can you can separate these precipitates, and these precipitates you can dry them overnight and then the nanoparticles will be formed. Okay, so moving on, what do we have here is the aim in the co-precipitation is to prepare the multi-component material. So what we are going to do, we are going to prepare multi-component material. For example, in case of this here that you can see on the screen, we have magnesium chloride and aluminum chloride. The multi-component mean we will get magnesium from one metal, and from one salt we will get magnesium, from the other salt we will get aluminum, and then combining both of these along with oxygen we can form the magnesium aluminum oxide. Okay, so using this method we can form the oxides, we can form oxalate, we can form hydrous oxides, and at the end what do we have is the chemical homogeneity when we perform the calcination reaction. Okay, so in the typical process of co-precipitation, what do? We just mix the aqueous metal salts, okay, at the sufficient temperature with the base, and this base acts as the precipitating agent. So here, as you can see, we have the magnesium chloride, the aluminum chloride. We mix both of them. This NH3H2O is the base, and this base is acting as the precipitating agent. And then when you mix both of them, there will be the formation of precipitate after standing still for 30 minutes. And then what you can do, you can just perform the suction filtration to obtain these precipitates. And when the precipitates are obtained, you can just try them. Okay, so the next thing is the co-precipitation reaction involves the simultaneous occurrence of nucleation, growth, coercing, and the agglomeration process. So all of these processes are occurring simultaneously. There is the nucleation, there is growth, there is coarsening, and there is agglomeration. All of these processes are occurring at the same time. Okay, so moving on towards the reaction, we have this cobalt chloride, we have this ferric chloride, and both of these will combine in the presence of sodium hydroxide. So when they combine in the presence of sodium hydroxide, this sodium will take away all of these chlorines and will form NaCl, whereas the oxygen from this hydroxide of the sodium hydroxide, the oxygen from the hydroxide of sodium hydroxide will go with the iron. Okay, we'll go with all of these irons, and then we have this another oxygen here. So both of these will combine and will give us cobalt iron oxide, whereas the rest of the hydrogen and the oxygen from sodium hydroxide and these 6H2O will cumulatively give out the 10 molecules of water. So what do we have here is the co-precipitation reaction in which the cobalt chloride reacts with ferric chloride and finally forms the cobalt ferrite. Okay, so co-precipitation reaction exhibit the following characteristic. The products are generally insoluble species formed under condition of high supersaturation. So what happens when there is, when you combine both of the salts, there will be high supersaturation, and then the precipitates will form. So here the nucleation is a key step, and a large number of small particles will be formed. After the nucleation, there will be formation of large number of small molecules. And secondary processes such as austral ripening and aggregation dramatically affect the size, morphology, and properties of the product. So in this case, the secondary process, you know about the austral ripening, you know about the aggregation. So these are the processes that will dramatically affect the size, the morphology means the shape, and the properties of the product. The next thing we have the supersaturation condition necessary to induce precipitation are usually the result of a chemical reaction. So the supersaturation occurs as a result of the chemical reaction. So moving on towards the co-precipitation synthesis method. So the metals formed from aqueous solution. So these are some of the co-precipitation synthetic method in which we have formed the metals that are formed from aqueous solution by reduction from non-aqueous solution, electrochemical reduction, and decomposition of metallo-organic precursors. And then we have the oxides that are formed from aqueous and non-aqueous solution, and then we have metal chalcogenides that can also be formed by the co-precipitation method by the reaction of molecular precursors. And then we have microwave by sonication assisted co-precipitation, in which we use the the microwave and the sonication. So moving on, we have advantages. So what are the advantages of this co-precipitation method? It is a simple preparation method, and there is easy control of particle size and composition. So you can easily control the particle size and the composition. And the next thing is that various possibilities modify the particle surface state and overall homogeneity. As you know, that the complete morphology and all of these things were depending upon here, as you can see, that the secondary process of osmolar ripening and aggregation dramatically affect the size, morphology, and the properties of product that I've just told you in this slide. Okay, so you can just control, okay, you can control the particle surface state and overall homogeneity. And the next thing we have is the low temperature. It's a low temperature process. You do not have to apply the high temperature like 180 degrees C, so you do not need any oven for that or any other specific materials. So it is also energy efficient, because you are not providing any energy. In case of the hydrothermal synthesis, for example, you have to provide the continuous heat energy to form the particles, while in the case of the co-precipitation reaction, the temperature is low. So and secondly, so it is also energy efficient, because we are not providing any external source of energy, and it does not involve the use of organic solvents. So these are the some of the advantages. And now moving on towards the disadvantages. Well, this is not applicable to uncharged species. So the co-precipitation method is always applicable in the case when the species are charged, when the species have some charge. So trace impurities may also get precipitated, so we can have some trace impurities along that. This is a time consuming process, because sometimes the precipitates to take overnight, okay, so take 24 hours to form. So in that case, you just have to leave the solution for overnight for the precipitate to form, and then the next day you have to then dry them again. It will take another day to dry them. So another thing that we have is the batch to batch reproducibility problems. So we have this reproducibility problems, and this method does not work well if the reactants have very different precipitation rate. Okay, so if the reactants both have the same precipitation rate, only then this co-precipitation will occur. The word co-precipitation means the precipitation at the same time. So if we have the precursors that have different precipitation rate, so the co-precipitation will not be applicable for that. So this is all for the co-precipitation. See you in the next video.